Hello, geometry ladies and gentlemen. Today we're going to be talking about trigonometry applications, so real world problems, and then the inverse trig functions. I do not have a foldable for you, so you're going to have to write all this stuff down in your notebook along with what I write. Remember, every slide that has a pencil written on it is what you're going to have to write down. So what you'll need today is a calculator, pen or pencil, and your notes. Remember back to our intro to trigonometry, we talked about how in ancient times it was often used in the measurement of objects that could not otherwise be measured, and this is often way back when they used trig to find the distance between the stars and the earth, way back when people were studying astronomy and then they didn't have any better means, so they used this kind of math. So we're just going to go right off the bat with 3 examples. So if you want to write down the full word problem, you can. Otherwise, just draw the image and everything else. So at a point on the ground, 50 feet from the foot of a tree, the angle of elevation to the top of the tree is 53 degrees. Find the height of the tree. So our picture would look like this. And when we say angle of elevation, here I'll highlight it in a different color, the angle of elevation, that means that from the ground looking up, that angle, which is this angle right here, from the ground looking up to the top of the tree, that angle. So we want to find the height of the tree, so this would be x. So remember SOHCAHTOA, we need to figure out if we're going to use sine, cosine, or tangent. SOHCAHTOA. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So we're not going to use sine or cosine, right? We have opposite over adjacent. We don't have the hypotenuse length. So we're going to do the tangent of angle 53 is equal to opposite, which is x, over adjacent, which is 50 feet. So what we want to plug into our calculators is 50 times the tangent of 53, and remember, for now we're going to round these decimals 4 decimal places, and we get for an answer that the height of the tree is approximately 66.3522 feet. So that's approximately the height of the tree. So our picture is a little bit not drawn to scale, but that's all right. Moving on to example number 2, in Washington, D.C., the Washington Monument is 550 feet tall. If the angle of elevation for your line of sight is 75 degrees, how far away are you from the base? Your eyes are 5 feet from the ground. So this is what our image should look like when we draw it out. There's the Washington Monument. It's 550 feet tall, but we also have to keep in mind that our person is 5 feet from the ground. So the height of the base of the monument to the top is 550 feet, but we're talking about the line of sight from our eyes to the top of the monument. So we're actually going to use 550 feet, right? Because this is 5 feet for the height of the guy, also tacked onto the monument. So we need to figure out the distance we are from the base of the monument. So we're not going to find the hypotenuse, so again we're going to need to use tangent, and remember my 75 degrees is an angle of elevation, that's why it goes right here. So we're using tangent of 75 degrees is equal to the opposite side length, which we found out is 550, not 555, because we're 5 feet tall and we're talking about our eyesight here to the top of the monument, all divided by x, because that's what I want to find, the adjacent side to my 75 degree angle. That's what we want to know. How far away are we from the base of the monument? So in order to solve, remember we have to multiply both sides by x to get x out of the denominator. It'll cancel the x's on the right hand side. We get x times the tangent of 75 is equal to 550. But now we have to divide by the tangent of 75 in order to get x alone. And that's what we're going to plug into our calculators. 550 divided by tangent of 75, we are approximately 147.3721 feet away from the base of the monument, and that is my answer. Moving on to number 3, A 60-foot lighthouse sits on top of a 150-foot cliff. The angle of depression to a boat is 27 degrees. First, I'm going to note that we have an angle of depression, so I'll talk about that in just a second. And we need to find the distance from the boat to the base of the cliff. Okay, so let's first draw a picture. So we have a 60-foot lighthouse, so this is 60 feet, on top of a cliff, which is 150 feet, and then we have some waves, and we have a boat sitting out here, and they told us from the lighthouse we have an angle of depression about 27 degrees. So if the light were to be shining directly straight out into the water, making a 90-degree angle, we're saying that the angle of depression on this guy is this angle right here. I don't think I made that very clear when I talked about it last week, but an angle of depression, when we say it's looking down, if you were looking straight ahead and then looking down, that angle that it's creating. So it's this angle right here. So this is our 90-degree angle. We know that if this was a 90-degree angle, this right here, we take 90 minus 27 to get 63 degrees there, and then my other angle down here would be 27 because 180 minus 90 minus 63 gets me back 27 degrees. So those are the three angle measures in my triangle. All right, knowing that, we also know that the entire height from the shore, or the water, I should say the water level, to the top of the beacon of the lighthouse is going to be 210 feet because that's just simply 60 plus 150. So, question now is we need to know this distance, the distance from the cliff to the boat. So are we going to use sine, cosine, or tangent? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then we have tangent, which is opposite over adjacent. Again, we don't know the hypotenuse, so we're going to have to use tangent. So I'm going to use tangent of 63. So tangent of 63 degrees is equal to the opposite side, which is x, all over the height, which is 210. Remember, we're adding the 60 plus 150 to get a height of 210. So we multiply both sides by 210, 210 on both sides. So what we're plugging into our calculator then is 210 times tangent of 63 times tangent of 63. Let me just punch that into my calculator. And we get that the boat's distance is approximately 412.148 feet from the base of the cliff. And that is my answer.